We're going to be continuing on some of the themes that we explored in our lecture earlier this afternoon with regards to test case design. Reflecting the fact we can't exhaustively test components of our system, we have to pick judiciously how to make best use of our limited testing time, testing effort. And that involves choosing savvy test cases, or test cases that are more likely than not to reveal different types of defects that are more likely than just shots in the dark. And there are some principles that can guide this. The videos I asked you to watch on orthogonal array testing, on coverage testing, both provide certain types of frameworks for informing the design of tests. With coverage testing, testing that systematically seeks to make sure that different areas of the system are tested and different transitions to those areas. And for more sophisticated types of coverage testing, different types of paths that you can take through the system are called prime paths. Yes, Tanner. Yes. Yes, there are tests for tests. It's a very good question. And this is actually a well-traveled area of testing that for more complicated tests, you want to make sure the test isn't, that it's actually testing what you want it to test, right? Like that it's actually exercising the area of the system, getting to the right places in the system. Some years ago, in a classroom very close to here, maybe in one of these neighboring ones, I had a team that reported to me impressive test reach within their system, and they compiled output from the test to demonstrate that they had tested different areas of the system. And I was impressed until a certain point when I started to look closely at their test output. And I saw that their test, while it nominally was going through steps system-wide within their program, testing different user actions and so on. In point of fact, it never got past the login screen. It didn't successfully log in. And when I studied when I studied the test output, it became obvious, like that it wasn't, in fact, exercising what it claimed to. And they were, effectively it was doing things like pressing the buttons to do this, do that, trying to grab a drop down, but there was no drop down. It was trying to press buttons that didn't exist. And it served no human purpose. I mean, it didn't go anywhere. It was full of sound and fury and signified nothing. And that's an example of a test which needed to be tested. Like it needed evaluation. Like, is it in fact working as a test to achieve its goals? So, with problems that can come up, sometimes the problems are ones of design of a test. Sometimes they're ones of implementation of that test. And, is the design good? What you want to test makes sense, but your implementation of it neglected a part of it? Or is it that like your intent to test something is making use of test approach that is not effective for that? So the idea, the structure of how you're approaching it is off. versus the implementation of a plan. And theirs was an implementation thing. It was a simple thing, like they didn't have the right mechanism to log into the system. And so it just served no purpose. And so, yeah, there are tests that test. I don't require those in this class. But you obviously want to look at, it's one of the reasons I ask students to look at outputs from those tests to make sure there's an indication like it's actually going through the requisite steps, because otherwise, it may not get off the ground at grad, step 1 or 2. UI tests are particularly vulnerable to this if they're not written in a careful way. Sometimes the test can include confirmatory checks, like, okay, I entered this into this text box. I press this button. Does the button exist? First of all, did the text box exist? If so, I press it and look at the resulting screen. I should see these things, and I navigate to the third one or whatever. It can do some testing, like assertions, essentially, that it's getting the response it writes, that it's expecting. And that could be, if it fails, if that check fails, it could be a problem with the system, like the system's not behaving properly. You entered this thing in a search string, you pressed, search, and it didn't go anywhere and didn't get you the list of results you expected. Or it could be a problem with the test. Like the test is testing things that shouldn't come about with the system, or it's checking them in the wrong way, and it gets back results that are different from what it expected. So yeah, tests can be correct or incorrect, and they can be incorrect at the level of design. The concept of what you're trying to accomplish doesn't make sense, or doesn't accomplish a goal, or it can be wrong at the level of implementation. But in short, Tanner's question is an informed one. There are times where we test our tests. Any other questions about tests? So it's describing ways of testing more savvily, more thoughtfully. Yeah, testing tests of tests. Yeah. You're thinking like a computer scientist. Congratulations. So there's ways of testing more savvily. Coverage is one of them. Are we reaching the right areas of the program? Are we exercising it by going through different transitions of the program? You should have seen this in the video, right? Whether it's the high-level UI. Remember, I have you for your IDs give me like a UI flow diagram, like the states. Those are like prime areas, no pun intended, for testing. Like you can test. Are you exercising each transition in that UI? Or exercising the different error ways you can leave one screen so that you're exercising it well, right? Are you at least getting to each screen in some tests? If you're not, like, how can you say you've seriously tested your program if your tests have never gone to a certain screen, right? If you've never gone to the map screen or something for the vaccination app, or if you've never gone to the screen which allows you to, has an error message shown for having specified an incorrect CSV file, a CSV file that can't be read. Can you really say you've thoroughly tested it? I don't think you can, right? So there's coverage testing, whether it's state-based or transition-based or simple path-based, where you're dealing with paths. These are different levels at which you can capture exercising a program's functionality. You can test it at the UI level, and you can test it at the level of particular branches within code. I mentioned the other day, this guy in the office next to me who was testing one of the central functions in Excel, right? And it had lots of branch conditions, and he was systematically going through and making sure he got each way that branch could go at every branch in the code and made sure it did the right thing for each of those. Because he knew, rightly so, that over the course of its life, that code each way the branch could go would probably be exercised tens of millions or hundreds of millions of times each, and it had to be right. Okay, that's coverage testing. Testing savvily in a certain direction. Another was orthogonal arrays. I'm going to come to that and link it up with what we're talking about now. But in my lecture earlier this afternoon, I talked about a certain type of testing that involved reasoning about what? Can anyone say? I used a certain technical term for it. It was a term you might have heard about in 260 or in the math, discrete math course you take before you take 260, whose number I can't remember off the top of my head. It's a math course and discrete math. The term is equivalence-Class. Equivalence-Class testing. So I'd like to jump into that. I'd like to wrap that up. I'd like to talk about boundary value testing. And then I'd like to link it in with orthogonal arrays. And we'll probably run out of time at that point. But it will be linked into that video you watched on orthogonal array testing. And I'll be giving the high-level shtick on orthogonal array testing, the high-level lowdown, the high-level gist. We good with this? Let us begin. Okay? I'm going to miss you folks. Okay. I know the feeling is not necessarily mutual, but that's okay. That's okay. Okay. So I know what you think, like Osgood's got to get out more. Okay. So I had left you with a query. I'd left you with a challenge, a puzzle. So suppose you're on a web form and you could pick a day. So you're searching for flights. And you're being asked what day you want to search for your only flight or your flight, flight goals start and or your outgoing flight, and you'll do another one for return. And here you enter a calendar day through a picker. All you calendar pickers, right? Pick a date. This is a little bit different from entering a string. We talked about the strings before, right? And there you could have a misformatted string. You could have a misspelling of the month. You could have something that's not a month. You could have a date that's, that doesn't exist. A date February 29th for a year, it doesn't have one, etc. Here you actually have a calendar picker, which has certain types of errors it rules out, but it can have other things that make sense or don't make sense. So if you think about things to test to make sure the calendar picker is doing the right thing, it's giving you the freedom you need or ruling out certain things, and thinking about ways that maybe something could go wrong, what's one sort of input you might pick for a calendar day? You want to be sure to test an example of at least one example of what? What would you want to test? We're talking about equivalence classes, so you want to think like, I want to have at least one that has what? Yes. Rob, you're here.
Yeah.
You were online before, right? Oh, okay. Okay. Welcome. I'm welcome. No, it's great to have you in person. Okay, so you where you pick say that again? A prior date, yeah, a date in the past. Now, you might think, well, wait a minute, calendar pickers can rule that out, and that's quite right. But you want to be sure your calendar picker, this is your software. You want to be sure you program it so it'll rule out anything before the current date, right? Doesn't make sense to pick a date in the past. Now, you could quibble about this a little bit, but probably that's a good rule, right? Yeah, I mean, you could get, okay, look, so I'm in the Central Pacific. I'm just over the date line. And, I want to be able to pick a date that for where I want to go from, it's yesterday. For me, it's like today. But let's not get into that. It's just, there are some interesting challenges, right? If I'm in Australia, what's, 9 o'clock in the morning there might be 4 p.m. here the previous day, right? So to speak. And you have to be a little bit savvy to these things. But that would be a good example. You try to pick things in the past. It should rule that out. It should either detect it if it occurs. If your calendar picker allows you to, you got to detect it and handle it. Or you can rule it out with the calendar picker, right? What's another? So that's a great example. That's a whole class of things. So you want to make sure if it handles one of those, chances are it will handle the others pretty well. So you want to be sure you get that right. What's another type you want to get right? You want to test. You want to make sure you've handled it right. Yes. Oh my gosh. This is embarrassing. Okay, my mind is going blank, and I'm sorry. Name? Steven. Okay. Today. Yeah. So you want to. Today is a good day, right? Today is a good day. If you look at the news, you may not agree, but today is a good day to test. Like that. If you don't test today, you're missing the boat, right? You want to be able to handle that. However you do, right? However you want to handle it, you want to be sure you've got that case right when you're testing. Because that might come up a fair bit. Okay, how about another class of or example of a type of date that you want to be able to handle? Anyone else? So you want at least one that's in the future, right? Like you don't want to miss that boat, right? I mean, that's a key need. So that is absolutely key, and you want to be able to capture that. Yeah. Sorry? 29 Feb. Okay, excellent. So now you might argue the calendar picker should be like built-in calendar pickers should know about what years are leap years versus what years are not, and so on. So there's a question of what calendar picker functionality. If it's a home-rolled one, if it's one that you've created, you want to be sure that it gets that right. On the other hand, if you're using an off-the-shelf one that is a quality piece of software, you might trust that they got that right. But same thing, like you might want to be sure that your airline reservation system will handle that date properly. So regardless of whether it like knows that on this year there's a 29 Feb, in this one there's not, you want to be sure your system, when you search for flights, at least works. So that's good. That's a good one. It's a kind of special date. How about others? Yes, Jason.
But a date so far in the future that no planes have been booked.
Good.
That's like 5 years.
Yeah, I think that's great. Or yeah, 5 or 10 years in the future that there's no established schedules then, and so you might want to test that capability of the software. Like how does it handle that, right? And the truth is, you might get that input because there's a user hoping to book a flight after the disastrous reign of the current U.S. madman. I'll book my next flight to the U.S. Well, he's talking third or fourth term now, so I don't. But in any case, you might be booking in the future for a good reason, but you might also be booking in the future. The orange-haired menace. You might also be booking in the future for an accidental reason. This actually occurred to me recently with a calendar picker. Like I didn't realize it, but I picked a date that was the wrong year. I've been scrolling through it, and that may sound weird, but I think there were weird delays when I was pressing it, and so it just led to a wild thing. It was like picked off in the wrong year. And so it could happen for that reason as well. Yeah, right, right. Yeah, so in any case, these are thoughtful points. And I think you're getting the point. Like when you pick your test cases here, you want to pick thoughtfully, right? You don't want to just pick scattershot, whatever, what the heck. And you don't want to just pick one valid date and leave the rest. You want to pick systematically, like some in the past, some that are like today. You know, that's an important day. Some that are, you know, legitimate in the future. Maybe tomorrow would be another good one. Maybe yesterday, and we'll come to that. But also some that are too far out. Okay, login field. Login fields. Okay, so you have a web page, or you have a smartphone app. The user can enter their email address, and you know, you press login or something. What things do you want to handle? Well, yeah. So that's kind of a blunt term. Does it work, right? Because it's more than just a matter. So that's a rather enveloping term, right? Like it's very broad. So I'll ask Ron there. Yeah. Good. Special characters would be a really good thing to make sure. You certainly don't want it to crash or hang, right? And you also don't want it to use a technical term, freak out, right? You don't want it to engage in unpredictable or unpleasant behavior where it, you know, spews out distressing messages to the consternation of users. Yes, Connor with an E. Okay, so that's good. Like you might, maybe in your code, you know, that it keys off the presence of an @ sign, that it searches for that or something to parse it. And so you want to test it certainly with some with it and some without it, right? And maybe you want to try it like with 2 @ signs in a row. That would be an interesting one. Yes, Rob. Good. Great. I don't know how many of you folks have taken security courses, but you know, sometimes there's exploitation techniques and techniques to counter them with like string sanitization and so on, which deliberately, like a hacker will try to insert SQL in a query, and they'll do so in a savvy way like that tries to comment out the code that would normally run and instead have this code run instead. And the hope is, if, don't tell me, you have a 1-tier application or something where you pass that directly to the back end, because you shouldn't have that. But if you have that, it's a security risk because you're passing on directly a string from the front end directly to the back end to your SQL database, and bad things can happen. Take it from an old man. And you can have that code like the select star from, you know, from users or from user credit cards or something, and you know, it displays all those things. So there you want to be sure that you can't, that it will catch sort of SQL-like things or things outside of a certain format string, right? A certain form of it. So all these things are good things. What is something though we definitely want to check? Yes. Good. We want to make sure it handles legitimate types of email address, but those fall in different categories. So some have capital letters, others have, yeah. Oh, is there a hand up back there? Okay. It's a phantom hand. Yeah, I know. Maybe that's why. So So some email addresses might have dots in them. Some might maybe have dashes. Back when I was a young man and we were like, when we weren't banging rocks together, we had like exclamation points in some emails. So you route them through like UUNet to ARPANET and out into to different academic labs and so on. And so email addresses come in a variety of forms, and you want to be sure that you've explored, different forms email addresses can take. And I don't know all the rules for that. Like, I'm sure there's many characters that are ruled out, but there might be certain special characters that are, well, there are, right? Underbar, I'm pretty sure is allowed. Dot is certainly allowed. Yeah. Yes, an empty field, exactly. Excellent. So these, Jason, yeah.
One more escape character.
Excellent. Excellent. Exactly. \n or \Unicode. How about things in other languages? Yeah, Unicode, like paste in things in other languages. Could happen. Like sometimes I'm typing in a different language. I even set the IBus or whatever to the correct language, and I type something and press enter before I realize that it's a different language. And you want to make sure your app doesn't wither, right? Right? Or worse. Okay. Topic field in a journal entry. What equivalent classes would you, like sensible things would you want to be sure to have an example of each? Yes. Empty. Excellent. Empty is a good one. You certainly don't want it to die if it's empty. It should do something intelligent if it's empty, maybe even if it's given error message, right? But it should handle it in some way. What's another thing? What's another type of thing you'd want to do? Check. Yes. Good. War and Peace in there. Yeah. Yeah, good. So you put in something that's too large. How about other things? Just riffing off of some of the other ideas I've had, Ronan.
Getting words posted.
Yeah. It's true. Like maybe depending on the forum, as you said, like maybe there are certain guidelines that this should not, that you should not allow certain types of profane utterances or something like that, right? So depending on the circumstance, that could be appropriate. Yeah, Alex. Good. Yeah, SQL, indeed. And this is a security issue, right? So you'd want to be sure. And in fact, overly long strings could try to be causing a buffer overflow problem, where if you're in a less secure language like C, you put a large enough thing and it just blindly allocates something in a way that, it blindly copies it into a buffer that's a maximum of 256 characters, and it goes over in ways that inject, either bytecode or inject a machine language code there, and then you get it to go execute that, and the hacker laughs and cackles, and they break into your system, and you cry. So these things can happen. Other languages, right? Someone might elect to put text in their own language. So like all of these are indicative of broad classes, and you want like one of each to not be embarrassed if someone asks, hey, have you tested it with empty? Have you tested it with a reasonable one, right? Like reasonable, and there might be different types of reasonable, right? With multiple words versus one word. Non-printing characters would be another thing, right? You have tabs in it. You don't want it to engage in silicon meltdown if it has a tab in it, right? At least I wouldn't. want it to. And I don't think you'd want it to in front of me, under my gaze. So students in this class used to have the dubitable pleasure of delivering to me their projects at the end of this class. And they would stand in front of me and I would interact with them. And I would pull out various tricks and they would get startled responses sometimes about, like, what do you mean you can't place Chinese in that? Like, oh, come on, you can't be serious about copying that entire novel into it. Or like, Unicode shouldn't be allowed there. And, I'd elicit crashes and gasps of disbelief and internal degree of pleasure, and bringing it to its knees. So look, testing like this, it's not rocket science, but it takes systematic thinking through. You don't just throw things at the wall and guess whatever happens and randomly try things. You try to be a bit thoughtful, and it can really pay off. Chances are, if it handles Unicode, in a certain form, if it handles special characters in a certain form, you've ruled out whole classes of errors like that. And so it's being intelligent about your limited test time, put it into different types of things that are likely to rule out whole classes of errors that could otherwise happen, right? You don't need to test all email addresses with periods in them, but you have to test one or two to make sure that if there's one or two periods in it, and that it's not going to cause a problem, right? And you've ruled out whole classes of possible problems that could be there. So it's about being sensible. And what I'm trying to communicate in these little examples is, like, what this looks like depends on the type of input. For a calendar input that's from Picker, it's different than from a string for the calendar date, different from a web form which asks you to enter, a string to search for, or a regular expression to search for. What is kind of reasonable, or what are reasonable error cases will differ based on those things, the rules of regular expressions, and you just want to think about these things. So these are the sort of types of questions I might ask you. Give me some well thought through. When I say well thought through, I just mean thoughtful tests for these. You've come up with a bunch of them in this room. Keep it up for the final exam. Keep it up. And I think you'll do well on that side, right? But I think you know what I'm getting at, right? And it takes a bit of thinking, but it's a bit of fun also. It's like a little puzzle. Like, how could I develop confidence as to whether there's a defect in there or whether it's, robust? And each of these equivalence classes will give you clues, far beyond one random case. It will give you clues as to whole types of errors that are either handled well or where it's failing to handle them properly. Yes, Jason. Oh yeah, we talked about string sanitization, but basically it's ruling out SQL code, and this is the subject of what are called sanitization libraries. So they will take in like strings and allow you to. We talk in, at least this was the terminology a number of years back, when we have strings, are they a sanitized string or unsanitized? Where sanitized strings have gone through a check that they don't include SQL, or if they do include SQL, it strips out certain key characters like dash dash, which encodes, basically starts a comment, or strips out star, etc. And so it kind of defangs it.
Okay, that makes a lot of sense. So we would just, if we wanted to write an equivalence class, let's say this thing, we would say like, string sanitization. Class like a string sanitization.
Sanitization is eliminating a type of problem like with SQL, but you'd say hopefully your system. So, good question. Your system should handle things with SQL in it, because there could be. It's a bad world out there. Like there they're nasty folks. Besides those in the White House, like it's a nasty world out there. I don't know if you've ever put like, you know, systems online, looked at the weblogs. Like there are creepy characters out there that will like try to find vulnerabilities and things you put online, and sometimes it's script kiddies, sometimes it's more serious folks. But the point is like you got to be prepared that people could try to do bad things to your software. So what I would ask for is like when you list test cases, you say an example with SQL code in it. That would be an example of test case. You expect it to handle it robustly. Another example would be a blank. Another example would be a plain text field with normal, you know, ask purely alphanumeric characters in it, right? Or for, you know, for this, you know, with Unicode, you know, other characters in other languages, non-ASCII support, yeah, and escape character, you know, an example with escape character. And the question is, does it handle it well? Sometimes it'll handle it well by saying, thank you very much, I'll do exactly that. Sometimes it will say like, we don't do that here. Like, go back and you know, like, I didn't understand your input, you know, re-enter something. But the point is, does it handle it robustly? And you're going to be wanting to think about the different types of things that should handle in different ways and give an example of each. Well, I mean, when I said, like for the search string, SQL code, I view it that as one type of input it should handle without breaking down, without.
Give an example of this test case, and we say, oh, SQL code case. You have to write SQL.
No. I'm saying like specify to me in English for this case. You know, that you would say, I would give it at least one example with SQL code and make sure that it works correctly. Now, if you told me, look, I would give one example with an SQL insert statement. I'll give one example with an SQL, and at least one example with SQL and a comment character, like dash in it, an SQL comment character. Like, I would reward those too. Like that's thinking at a more granular level about like when you say give it SQL, that's kind of blunt, that's kind of non-specific. I mean, it's very non-specific, and you could break it down. And I would say, oh, Jason's thinking in structured way about this. And really those are different equivalence classes, one with an SQL comment character versus one without, because SQL comment characters play an important role in break-in attempts because they can be used to like, if you just stick that string in the middle of an SQL query, it can be used to like cover the rest of the SQL query so that you replace it with your SQL query. That's one way they break in is, you know, they basically disable the SQL query in your system because they say, oh, maybe this developer has been crazy enough to just take this string, paste it with another string that's the rest of the query. And if that's the case, I just have to put a SQL comment character to the end of mine, and that will block the rest of the string and allow it to just run my query. And yeah, it's a nasty world out there. Anyway, yes, please speak on, young Rob. Yeah.
Modifying the front end, like, you know, inspecting and people check back for vulnerabilities, like see what your front, like, feel like a really basic system. You could look at the code and then mess around with that.
Yeah, you're saying like actually look at the underlying JavaScript and so on. Yeah, I mean that's a very good point, and I think that would fall into a list of vulnerabilities because there are SQL techniques to obfuscate code and so on, obfuscate JavaScript code, etc., that can make that less likely. And so that is an aspect of the interface of your system that someone might exploit. and that interface might not be a vulnerability for a smartphone app, for example, that's not based around, web technologies. And so I would give strong credit for something like that. That, yeah, you want to ask, well, suppose they were to decompile, like we want to make sure that the code is not understandable. It's a little bit more of a broad area, and so, but it shows good thinking. Yeah. So look, this is about not testing wastefully. It's about not spending your time just throwing things at the wall and just seeing what sticks, randomly testing it with, search strings that are all simple simple English phrases. You don't want to test your login for your smartphone app with all legitimate Gmail addresses or something like that. You're wasting your time. Those are not going to be high leverage, high return. Each successive one is not going to test the system materially more than you've tested previously. Putting in blank ones would. Putting in ones that have no @ sign. Putting in ones that are, contain invalid characters would test. Putting in things in other languages could test things and could rule out types of errors. Does this make sense? Okay. Time is running short, so let me introduce one more principle because I was hoping to hit on it further. Right. I want to talk just a little bit about boundaries of equivalence classes. We've kind of been dancing around this issue, but there are equivalence classes. There are the boundaries between them. We saw it earlier in Jason's remarks in the other room, in fact, where he mentioned like the example of 0. 0 is interesting both in its own right, it's the square root of itself, etc. But it's also interesting as kind of the boundary between illegal values for that square root -1. We're pausing, it handles, I mentioned, only non-negative values, and values to which you can apply it. And that's the first of them, right? And there can be bugs at these boundary values. Why do I say that? Why can there be bugs often at boundary values? What can we as programmers, one of the most common types of mistakes for us as programmers? An implementation mistake. Yeah, Tanner. Yeah, end of loop is a good one, and that can often mean you don't go quite far enough or you go too far in that. And also it's mistaking, like, yeah. Okay. Yeah, that's true. That is a very good point, and that can lead to boundary. That's right. So the, -1 may be encoded with, OXFFFF, in hexadecimal, right? It's all ones from there, right? From -1. So that's a very good point. I really like that. What's another one is like you put in your code. For Jason's case, you check in the code, the square root function maybe checks, is this value greater than 0? If so, it'll handle it. Otherwise, it says it will return an error condition of some sort. And it should be greater than or equal to, but we put greater than. This is very common. Especially because the flip, the converse of like greater than is less than or equal to. And so sometimes we get confused in our minds and so on, particularly if it's too late at night, particularly if you're under pressure for 371 deliverable due in an hour, and you're trying to fix a bug, and you put a greater than instead of greater than or equal to. You can easily get these boundary values off, right? And often they are worth thinking about, especially carefully. There are these values that are kind of between types of equivalence classes, where on the one hand it's handled this way, the other hand it's handled that way, and the boundary value, it's easy to get it wrong. It's easy to put it in the wrong class, and or to not handle it properly. So boundary value testing and equivalence class testing support each other. And testing boundary values help test, you've got the equivalent classes right in your code, that it's handling the right thing. So, there's kind of boundary values for email addresses, like things that are almost at the boundary between an empty one, like or completely blank and it's not allowed, versus like a legitimate email, where it's like an absolutely minimal size email, right? And similarly for like names, right? There can be names that are like really short, or names that have only one name in it. I've met quite a few people in my life. Had a professor who had one name. No, not a surname, not a given name, just one name. I've met people here at the U of S who have one name, and I'll tell you, IT systems do not like them. So the guy I met here at the U of S, I think he had his name, I forget, if memory serves me, and I'd have to think about it, it had his only name began with A, and so they gave him an NSID of like XXA. But they had to be able to handle it. And to their credit, they could assign an NSID. It didn't just like crash and say like, you're not allowed to have only one name, So boundary values, like minimum ones that fall into this class, that are on the edge, right? The minimum number that's not negative, 0, right? The minimum perfect square, that's not 0, which you could argue is 1, or if you want to rule out 1 because it's a fixed point, 4 or what have you. You want to think about boundary values. So age is a good example. Someone gave this earlier, right? For age, 0 is a good age, right? Or the maximum legitimate age. I think Connor said it, right? You figure out the oldest someone's ever lived, right? I know people have lived into their, I think it's late 120s. And I'm not sure if there's even someone who's reached 130 documented. I think like 127 or something like, anyway. So like minimum -1, minimum, maximum +1. Think about this for like double precision values, or things just over the boundary, the max double, and then just the minimum double, and maybe if there's any kind of boundary that when the bits change for the floating point representation is something else, you try that. Sometimes it makes sense, sometimes it doesn't. You have to stretch your imagination, but these are not perfect things. It's just like, what's the minimum legitimate email address, or what's a minimum thing that would be an illegitimate email address with weird characters and non-alphanumerics in it, exclamation point or something like that. You want to test, and hey, this is better than testing just totally, sloppily and willy-nilly kind of in a totally unfocused way. So boundary values for minimum title for a smartphone app, right? Or for a title of a journal entry. There can be kind of minimum ones. There can be maximum size of ones. Maybe it allows up to 256, and you want to test 256, that it doesn't crash the system because it handles actually just the 255, and they sized it to hold up to 256 characters, but they forgot, that the first character counts as index 0 or something. So you want to test it in a not bad way. The final thing I'll say here is just about combination. When we have multiple fields, first name, last name, email address, or whatever, often have equivalence classes for one, for another. In other words, each of them have equivalence classes. And often you can't test all possible combinations. This was the idea of orthogonal arrays. You often, especially with manual testing, or even if it's automated testing, which you folks know can take a while, you can't test all possible combinations of equivalence classes, perhaps. But the idea of orthogonal array testing is that you are sure to test every pair of equivalence classes for each one. So every pair is tested. So when I say pair, I mean field 1, field 2, every possible pair is tested. Field 2, field 3, every possible pair is tested. Field 1, field 3, every possible pair. But you're not testing every possible combination of field 1, field 2, field 3. This is what orthogonal arrays evolve. They don't test, instead of testing all possible combinations of 5 fields. Let me ask this. If each field has, let's say, 10 possibilities. Each field has 10 possible values, let's say. 10 possible equivalence classes we want to test. And there are 5 fields. What's the number of combinations of those? 100,000, 10 to the 5th. Good man. 100,000. It blows up geometrically. If we have one more, it's a million. One more field. And testing that, particularly through UI-based testing, may be completely impossible, right? Can't test all possible. But what orthogonal arrays do is they allow you to make sure, reflecting the fact that, and I'm about to let you go, reflecting the fact that often problems come when there's incompatibilities, pairwise incompatibilities, like this doesn't work with that. It doesn't handle this combination well. Pairwise, what you do is you test every pair. So you have field 1, every pair of it, and field 2 are checked. Pair 1 and pair 3, or field 1 and field 3, every possible pair is checked. Field 1 and field 4, every possible pair. And you check all those pairs, but you can do it vastly smaller than that. So you can go down from a number of combinations like this to a number of combinations like that. And if you watch the video on orthogonal arrays, you'll understand this idea. But the key point I want you to know for the final exam, the key point you need to know is that orthogonal arrays provide a way of testing combinations without testing all possible combinations. Instead, the key property it has is tests every pairwise combinations, but not all possible combinations of all possible values. And generally, it's the pairs that provide bang for the buck. Because if it's not a particular value in a specific field that crashes it or hangs it or whatever, it'll be a pairwise thing where this doesn't go with that. They don't play nicely together, and it does bad things. And so pairwise testing with orthogonal arrays lets you rule out pairwise problems with your system. Yes, you want to test that it works with every possible value of field 1, every possible value of field 2, every possible value of field 3, but you also often want to test pairwise, that testing choice 3 of field 1 and choice 5 of field 2 doesn't cause problems. Okay? Are any questions on that idea, the general idea of orthogonal array testing? That's the level I would ask you to know about it for the final exam. Any questions about that? You can go into more detail in the video. Are we good with that? Okay. Then with those words, I will close this session. And I will close the last full lecture of this course. I will make a little bit of remarks if people don't go over in their presentations, which they're welcome to. But if you don't, on Thursday, I will comment a little bit on next steps from this course, just thinking about building on the knowledge here. But this closes my last full lecture for the course, which has been the greatest of pleasure to explore with you today and in the past. Thank you.